Mr. Harris here, and welcome to a new video. In this video, we're going to classify elements. So we can classify elements into three categories. The first one being metals. The second one it is a non-metal. And the third category is, perhaps you might not have heard of this before, a semi-metal. Or what we say, you can use either name. Another name is metalloid. Okay, we'll talk about that later. But here, first off, how do we know what element or which element could be considered as a metal, a non-metal, or a semi-metal? So we can classify them based on their physical properties. So once we know their physical properties, then we can say, hey, okay, this element, it kind of behaves like a metal. It kind of has these properties. So it's a metal, it's a non-metal, it's a semi-metal, so on and so forth. So some examples of metals you can see on your left here is copper and aluminium. And on the right over here, some examples of non-metals are chlorine, iodine, oxygen, so on and so forth. So here's a table where you'll be given, I think, 8 physical properties. Yep, 8. So on the left here, we could base elements based on their appearance, electrical conductivity, thermal conductivity, malleability, and ductility. So appearance, fairly simple. It's just the way it looks like. Metals, they are shiny, whereas non-metals, they are dull, but they do show a variety of colors. Metals, they are good conductors of electricity, so they can conduct electricity well. But non-metals, of course, as we know, they're poor conductors. You also learned this in Form 2. Metals, they're good thermal conductors, meaning they're good conductors of heat. So thermal here, you could represent it as heat. Whereas non-metals, they're poor conductors of heat. Now the next two, malleability and ductility. Now what do they mean? This is usually where everyone gets confused. Metals, they're malleable, meaning so malleable, it basically means that you could press the metal or you can hammer them into a larger surface area. So like into sheets or like a plate. So maybe I'll write that down. You can press them into, or you could hammer them. So you can basically get a hammer and make them a bit wider, I would say, with a larger area. So hammered into sheets, or you can say a plate. Whereas ductility, or something being ductile, like metals are ductile, it means that you could lengthen them or elongate them into thin wires. So it's like you're increasing the length, but not really increasing the area into a wider surface. So maybe I'll write it's lengthened into thin wires. That's the meaning of ductility. So metals, they are both malleable and ductile. So here, for example, you could see copper metal is here. It's both malleable and ductile. Non-metals, on the other hand, they're not malleable and they're not ductile. Okay. On the next slide over here, metals, they're having high strength. That's, of course, it also has high melting and boiling points and also has high density. Whereas on the other hand, non-metals, they don't have much strength. They don't really have a high melting or boiling points. They're usually low, and they have a low density. Okay, so density is basically how heavy something is. So let's look at some examples of elements. Now, I don't know whether these elements are metals, non-metals, or even a semi-metal. So how can I classify them? So here, in the table at the back, we saw like a bunch of physical properties, right? So what we can do is, for example, if you find a new element and if you want to categorize them as a metal, non-metal, or a semi-metal, then you can just go ahead to this table and see whether it has these properties. And if it does, then you can assign them to whether it's a metal or non-metal. So, but let's look at these three examples here. Now, of course, they've already told you this is a magnesium, this is zinc, and this is sulfur. And maybe some of you already know which one is a metal and a non-metal, but let's still go ahead and see. So you can do a bunch of experiments just by seeing whether it conducts electricity or not, whether it's malleable or not, so on and so forth. But to save time, I'll just write the answer here directly. So magnesium on the left here, you can see that it's silvery and it's kind of silvery and it's kind of shiny. Zinc is kind of shiny as well. Now sulfur here, maybe I think it's off the reflection of the camera, but actually its appearance is kind of dull. So here, I know it's shiny, magnesium is shiny, it's a metal. Zinc is shiny, it's also a metal. And if sulfur it's dull, then I could already get the hint that it's a non-metal. But anyway, let's do the next one. Now, if you conduct some experiments to see whether it conducts electricity or not, then we will know it does conduct electricity, this one. Magnesium does conduct electricity. Zinc also conducts electricity. And sulfur, because it's a non-metal, it will not conduct electricity. Okay, the last property, we have malleability, meaning whether you can press it or hammer them into sheets. Magnesium, because it's a metal. And if you actually take a hammer and if you can take a hammer, and if you actually press, hammer them, and you will notice that they are indeed malleable. Now, please also pay attention to the spelling of malleable. It's Mallleable. Now, usually you would swap the A and E positions based on my experience. So please be aware of the spelling. This is also malleable. And then last one, because sulfur is a non-metal, and if you actually do the experiment, this is not malleable. Okay. So here, classify the samples of elements as metals or non-metals. Metals here, very simple. So magnesium was the metal, and the other was zinc. And the non-metal here, it was sulfur. Okay, that should be simple. Now let's talk about semimetals, or the other name for it was metalloids. Now from the name, you can guess it's kind of like a metal and kind of like a non-metal. So it's kind of in between. So it has properties of both metals and non-metals. Now usually it's brittle. The meaning of brittle is easily broken. Okay, it means it's sort of easily broken. And it's a shiny solid. Now this part, brittle, is this a property of a non-metal or a metal? Now this brittle bit, this is a property of a non-metal. But here it says it's also a shiny solid. Now this, on the other hand, is a property of a metal. So do you see it has both properties of a metal and a non-metal? Now this next bit, it says it does not conduct electricity well under normal conditions. Now this is obviously a property of a non-metal here. Okay. So some examples of semimetals or metalloids are silicon or boron. Okay. Some other examples, or some other properties could be that semimetals, they are good electrical conductors when heated. So this is a property of a metal. This is a property of a metal. and it's often used as semiconductors in circuits of electronic devices. Okay, so silicon, actually let's talk about silicon primarily. Silicon, as probably you've heard of silicon chips, is used quite often in electronic devices. Okay, so here, as I said, elements here, our focus is on elements. They could be categorized or classified into three groups, three categories. The first one, metals. The second one, nonmetals. And finally, semimetals. And how do we know that we could classify into these groups? It's based on their physical properties, and you'll learn 8 physical properties, 8 of them.